Good morning, and thank you for joining us for this webinar this morning in relation to hydrogen peroxide. We've been getting excellent feedback on these webinars. We're very thankful for that. We're very thankful for the input and common suggestions that have come back. So please be free to send your suggestions through. So the discussion today is in relation to hydrogen peroxide, which is a very, very important chemical in relation to cleaning. There is about 4.5 million tons of hydrogen peroxide used annually across the globe. Our little section of the market is a very, very small user of it. Around about half of what is manufactured is used in the paper and pulp industry. But hydrogen peroxide, there's hardly a product that has got such a myriad of different users. And our intention today is to be able to show you as to how we can use hydrogen peroxide to its best ability. There's many people using hydrogen peroxide that are not getting the best out of it. As a result, in some instances, it's a bit of a bad rap. We certainly intend to change that today in your perception, to show you how you can get the best out of it, use it to its maximum potential, and try and make it interesting as we go along the way. The hydrogen peroxide molecule has got 2 hydrogens and 2 oxygens. I realize this is getting into a bit of the chemistry of it, but it's important to note that water has got 2 hydrogens and 1 oxygen. So we've got an additional oxygen there, which is what makes the hydrogen peroxide molecule unstable, and also what gives us its efficacy in bleaching, destaining, disinfection, and obviously oxidization, which covers some of those as well. The hydrogen peroxide itself is available in 2 strengths, or 2 types, I should say. There's the liquid version of hydrogen peroxide, which we're mostly familiar with, such as the Perox, the Actichem Perox, which is a 50% strength hydrogen peroxide. Other popular strengths of hydrogen peroxide is 3% and 35%. 35% is very popular in other countries, European and USA, etc. So there are different strengths of hydrogen peroxide. So we need to ensure that we know what we're working with if we just use the word hydrogen peroxide. The active oxygen content in hydrogen peroxide of 50% is about half of its strength, so that's 23.5%, with an acidic pH. And we'll touch on that a bit later. But the other form of hydrogen peroxide is the sodium percarbonate. Now, sodium percarbonate, there's also other forms such as sodium perborate, etc. However, the one that we commonly use in the cleaning industry is sodium percarbonate. Now, you can look on that as a powdered form of hydrogen peroxide. When it is diluted, when it is dissolved in water, the hydrogen peroxide is released into an alkaline environment, which is where it works the best. The active oxygen content in sodium percarbonate is about half of what the liquid is, and the pH is in the alkaline region. So it's almost exactly the opposite, if you want to look at it that way, to the liquid. Now, one thing I'm going to share with you is a couple of very interesting blends, little formulas at the end of this presentation. The one being as to how you can make up your own Part A, Part B mix. So look forward to that, and let's move on and see what else we've got in relation to hydrogen peroxide. The hydrogen peroxide, as we've mentioned, is not a stable compound. It is always decomposing into water and oxygen. The way that we have it stable, we're talking about a liquid version now. Remember that the powdered version is stable due to its powdered format, which is one great advantage of sodium percarbonate. But in relation to its liquid version, we need it stable for storage purposes. Now, unfortunately, this is where it works at its least efficacy. It's in its comfort zone. We need to get it out of its comfort zone to make it work and active. So to keep it stable in storage, we need to maintain the acidic pH, which is the way it is supplied to you. We need to prevent exposure to light. We need to store it in cool temperatures, and also exclude contaminants. So think about the how you would be using it in your workplace. If you've got vans out in the road, hydrogen peroxide is certainly not a product that you want sitting on the shelf in a van in the sun all day, because it will very, very rapidly lose its efficacy. And the worst thing is that you won't know what strength you've got left in it. The one thing I did want to point out, though, is excluding of contaminants. Contaminants very, very quickly degrade hydrogen peroxide. 2 of the key ways that you can prevent this happening to your storage bottles of hydrogen peroxide is never pour or never return unused hydrogen peroxide back into its original bottle. Always discard what you don't use. The second thing is always make sure that you put the cap, put the lid back on the bottle straight after decanting it. Now, moving on to how we get it to work for us there's a couple of key items there. We need to increase the pH to the alkaline region. We'll touch on this in a little bit more detail, but just to run over those basic ones, increase the pH, provide external heat source, provide a catalyst, and provide time. Now, in simple terms, on the top left-hand corner of the screen there, we've got in simple terms the hydrogen peroxide releases oxygen. Now, that release of oxygen is one of the key reasons why hydrogen peroxide works so well, the oxidizing agent, as we call it. It changes the molecular structure of color molecules, especially the larger color molecules, and it is very selective in that. So hence the fact that we can remove stains from fabrics without removing the dye of the fabric at the same time, as what happens with chlorine or some of these other oxidizers. In disinfection, it breaks down the pathogen cell, the DNA structure. There's a few different mechanisms that happen there, but that's just in round terms that what's happened. But at a closer look, it's not just oxygen which is released. Yes, oxygen is released, but in many cases, we're able to form the hydroxyl radical. And this is typically produced by adding a catalyst or an activator into the mix. And hydroxyl radicals are significantly more powerful than just straight hydrogen peroxide. So the key thing for us is how to optimize the generation of these radical hydroxyls, which will ultimately determine as to the performance we get out of it. Now, I'm going to show you as to how we can do that very, very simply in our everyday dilution and working with hydrogen peroxide. So the optimizing of the hydrogen peroxide activity, in other words, how can we get these hydroxyl radicals happening to give us that much, much greater oxidizing action? So there's two things going on here, which I must make clear. One is just improving the performance of the release of oxygen, the hydrogen peroxide on its own. The second thing is the hydroxyl radicals, which are always going to be generated to some degree. We want to see as to how we can optimize that. So the increase in activity in an alkaline solution is very, very important to get the best out of hydrogen peroxide. Increase the pH to above 7.5, ideally is around pH 9.5, 10. Now, you remember on the previous slides, we mentioned that the pH of hydrogen peroxide in its stable form is around about 3, 3.5. So it's in its acidic area, which is its comfort zone. So to get it out of that, to get it working, we're going to push this pH up to above 7.5 into the alkaline region. Now, we also need to realize when we do that, we are getting the hydrogen peroxide working, which also brings down its usable life. So we're dramatically shortening its lifespan. Always mix up fresh hydrogen peroxide solution and use it immediately. In laundry situations, hydrogen peroxide is always added into the alkaline brake wash cycle, and that is so we get the most out of hydrogen peroxide in a multi-stage laundry situation. And the interesting thing is that chlorine is exactly the opposite. Chlorine works best the closer it gets to the neutral solution. So hydrogen peroxide and chlorine work exactly the opposite to each other. Two-part stain removers increase the pH to the alkaline region. That is one of the ways that two-part stain removers get us such increased performance out of hydrogen peroxide. Sodium percarbonate, as we mentioned earlier, the powdered version of hydrogen peroxide. The other part that is not generating oxygen or hydrogen peroxide is in fact sodium carbonate, which is alkaline. So that sodium percarbonate, when dissolved in water, is released into this alkaline region, which is why sodium percarbonate is so effective. The other way of optimizing hydrogen peroxide activity is in a heated solution. So we increase the solution temperature. Laundry, the hydrogen peroxide is normally added into a multi-stage laundry system in its hot cycle, which is where hydrogen peroxide is at its best in a heated solution. Once again, exactly the opposite of chlorine. Chlorine does not work very well in a heated solution. It requires a cool solution to get the best out of it. Two-part stain removers. Those in the carpet cleaning industry would be aware of the hot iron method, where we heat up the solution. So with a two-part stain remover, we're increasing the hydrogen peroxide activity by increasing the pH of it into the alkaline region. And then as an additional boost to it, we can then heat it as well. Sodium percarbonate, again, the powdered version of hydrogen peroxide, needs hot water for effective action. So typically we talk about 60 degrees, which is around the temperature of hot tap water. Lastly, dwell time is very, very important. The action is a chemical reaction. Hydrogen peroxide reacting with stains, bleaching, disinfection is a chemical reaction. Dwell time makes a significant difference. You can use a much lower percentage of hydrogen peroxide and greatly extend the dwell time to achieve the same results. For delicate surfaces, a weaker blend especially is preferred, but using the extended dwell time to get the same efficacy, to get the same results, but without the potential for damage to those delicate fabrics such as cotton especially. Many laundry soaps rely on dwell time, as we know. There's one last aspect in relation to hydrogen peroxide which makes a huge difference, and this is where many failures are found with hydrogen peroxide in their application, is a reduction of surface tension. The surface tension of hydrogen peroxide is in fact higher than water. So water has got a surface tension of just under 73 dynes or Newton meters, whereas hydrogen peroxide is at least 1 or 2 dynes higher than that. So it wets out its substrates with great difficulty, very inefficient wetting out of fabrics, of the soiling, of our stains. So the addition of a wetting agent will significantly increase the speed and efficacy of hydrogen peroxide. The one little note that I wanted to share with you, though, is that remember that the oxidizing propensity of hydrogen peroxide, when it's increased by using heat or alkalinity, means that it does work much quicker. It also works much more aggressively in getting our stains removed, our disinfection and mold removed, whatever it may be. But it can also damage delicate fibers. So especially in relation to cotton, some of these other very delicate fibers, wool, natural fibers predominantly, it can damage them. It can also affect those dyes. So for resilient surfaces such as synthetic fibers, polyolefin fibers, nylon fibers, all things like timber, stone, resilient surfaces, your boosted hydrogen peroxide solution is absolutely ideal. But for delicate substrates, such as cotton and wool fibers, we are far better off using a non-boosted version of hydrogen peroxide, but use our extended dwell time to achieve those same results. I've got a couple of slides here which I thought that you'd find very interesting in relation to the difference between using hydrogen peroxide on its own, just in its raw state, you might say, versus hydrogen peroxide, which has been activated, which has got wetting agents included in it, where the pH has been optimized. On the screen, you'll see a couple of test results which we had where we compared hydrogen peroxide at 8%, so 8% hydrogen peroxide, with our product Percide. Now, Percide is a 8% hydrogen peroxide too, actually slightly under 7.9% active hydrogen peroxide in Percide. So we've got, you might say the actives are the same across the two in terms of our percentage of hydrogen peroxide, but just have a look at the ability of Percide to create a far greater kill rate on the Aspergillus and the Penicillium mold spores and the vegetative state of it, compared to hydrogen peroxide on its own. So hydrogen peroxide on its own, both on the suspension test and on the carrier test, we're getting very poor results. So for instance, the 3.3 log reduction in Penicillium equates to only a 99.9% reduction as a kill rate, whereas the Percide is getting over a 5 log reduction. That is a 99.999% reduction of those Penicillium spores. Then the bottom one, which is our Percide Plus Boost, that is when we are boosting it, we're increasing the pH into the alkaline region. We're also adding additional activators to it. You can see there's another step up on its ability at reducing the spore count on those Penicilliums and Aspergillus molds. Very interesting. We can't just say, well, we'll just use hydrogen peroxide. Using hydrogen peroxide just on its own doesn't really meet our requirements. We did a further test in relation to bacteria, namely Pseudomonas aeruginosa and Staphylococcus aureus. So the Percide IC is a product which is a TGA hospital-grade disinfectant. It is also sold as the responsibly green mold remover, which is what most of you will know it as. This is compared to the 3% hydrogen peroxide. So Percide IC has also got 3% hydrogen peroxide in. Look how much incredibly improved pass rates we have on the Pseudomonas and the Staphylococcus aureus in those timeframes compared to just a straight 3% hydrogen peroxide mix. Very, very interesting. We've done a further series of trials, which I'd like to share with you too, in relation to stain removal of hydrogen peroxide with the ability to boost it and in its raw state. So we've got a series of swatches there. We have curry, and we have coffee and tea and red wine. Each of these swatches were treated with different forms of hydrogen peroxide. Let's see the results. So this series of swatches is the red wine. In the top left-hand corner is what the original swatch looked like. Then in our 6 experiments, the top left-hand experiment is 5% hydrogen peroxide. So that's just 5% hydrogen peroxide in its raw form. All of these were run at 10-minute dwell time. Moving across to the right, we increased that dwell time to 12 hours. So that one certainly bears out our theory in relation to the increased dwell time producing those results. Then we did 10 minutes, increasing the temperature of the 5% hydrogen peroxide to 60 degrees, and we got a nearly perfect result. Now compare that with the swatch on the far left-hand side. You can see the incredible increase in performance that temperature has given us. Moving just directly down in a clockwise direction, 3% sodium percarbonate is used also in its heated form. As we know, sodium percarbonate needs to be used at 60 degrees. Once again, we have a very, very near perfect results. I'll say one thing for sodium percarbonate version of hydrogen peroxide is there's virtually not a stain that you'll come across that sodium percarbonate will not produce a near perfect result for. Then moving across to the peroxide A and B. So this is a part A, part B. Once again, we are increasing the pH up to an alkaline region. We are also improving its wetting ability, a near perfect result again. Now on the left-hand side, we have hydrogen peroxide with colloidal boost. So that was simply done to show the benefit you will get by simply adding a wetting agent to the mix. So wetting agent definitely produces a better result than hydrogen peroxide on its own. So the results are repeated with coffee. So we move across in a clockwise direction. You see the ability of hydrogen peroxide when it has been activated, when it has been boosted, when we have added a wetting agent to it. Then we have the tea. Once again, we move around the far right-hand one with the little red dot in the middle. That's just a phenomenon that happened in the laboratory. So just ignore that. But you see the results that we get out of hydrogen peroxide when using it intelligently, you might say. And finally, curry stroke mustard. Very, very difficult dye to remove, a dispersed dye, one of the most challenging to remove. Hydrogen peroxide, once again, comes out trumps. Stepping across onto the applications of hydrogen peroxide, I've got a series of typical applications that we'll find. Now, just remember, on the top left-hand side of the screen there, we've just written that it's 50% hydrogen peroxide that all of these quantities are based on. But the cleaning booster for synthetic carpets, we want to get it at 1.5% active. Now, I'm going to give you some of this on paper so that you don't need to remember this. You can screenshot it if you want to, but adding to an end cap solution or adding to a pre-spray solution, 30 mils per liter of your ready-to-use solution is the best option. Another note worth mentioning is that the addition of hydrogen peroxide as a cleaning booster is most effective on synthetic carpets. You don't get a lot of benefit out of using it on a wool carpet. So synthetic carpets, especially polyolefins, nylons, get a great efficacy on adding hydrogen peroxide to both end cap solutions and pre-spray solutions. Carpet and fabric destainers, wool fibers must be below 3%. An interesting note from the Wool Safe organization is that 3% is the max hydrogen peroxide you can afford to use as a spotter, and 1.5% as an addition to carpet pre-sprays. Synthetic fibers, however, we can afford to bump up to 5%. Cleaning, booster and stain removal for tiles and stone, sodium percarbonate is an ideal one to use, mainly because of its ability to also promote that alkalinity in the mix. And finally, disinfection in laundry cycles, both the liquid and the powder are used. Mold removal and biohazard decontamination, such as our very, very popular Percarbonate, based on hydrogen peroxide plus a secondary biocide. And of course, hospital grade disinfection. And it's used a lot in antiseptic use. in hospitals. 1.5% and 3% hydrogen peroxide are very widely used in disinfecting wounds, etc. Now, there's a myriad of different problems which the intelligent use of hydrogen peroxide can solve. There's a whole list I've got up on the screen there. In carpet cleaning, in household use, in hard surface cleaning, even down to cleaning of espresso coffee machines. We're going to give you a how to remove guide, which includes really easy little formulas for each of these applications, which will be very, very helpful for you. The last thing is, I told you that we'd give you a very easy to use part A, part mix that you can use on your own. This is 80 mils of water with 10 mils of Actichem Bust and 10 mils of Actichem Perox. That gives you a part A, part B oxidizing agent. So never spend money again on two-part oxidizers. Here you can mix up your own one. So remember that it is ideal for synthetic carpets, natural stone, concrete, safe on natural stone, being in the alkaline region. You can use hot water for even greater performance, which gives you that added benefit that you possibly don't need to use the hot iron method because you're making it hot with the water that you're mixing it with. Remember that natural and delicate fibers can be damaged by these activated versions of hydrogen peroxide. So dilute the above blend 1-to-1 with water for these delicate fibers. Now, remember there that the more you boost hydrogen peroxide by adding heat or alkalinity, the faster and more aggressive it'll work. But remember, this can also damage delicate fibers and dyes. So just remember that, keep that front of memory, especially in your training of your technicians. And always pre-test if you're concerned. Remember that this type of little mix must be used within 30 to 60 minutes. So thank you very, very much for joining. Trust there's been some takeaways for you. Thank you very much.